Hi, I'm here with Robert Taylor from Texas Instruments, and Robert's going to take us through a couple of interesting demonstrations with gallium nitride power technology and what you can do with it. Robert, what do we have here?
Yeah, Lee, thanks for taking some time with us. This is a 6.6 kilowatt onboard charger, and we have a number of gallium nitride devices on here. So you can see our topside cooled devices are shown here. This is the PFC section, and then an isolated DC to DC section over here on this side. Now, this AC to DC converter, this is an interleave two-phase PFC, takes the AC input and creates a DC bus. And then this is the isolated DC to DC section. Now, this guy is 6.6 kilowatt C-triple-LC resonant converter to charge the battery.
Huh. How big would this be if you had to do it in silicon?
Oh, that's a good question. So a lot of these conventional types of inverters here that are use silicon devices, and because we're able to run at a higher frequency, we can make this transformer much smaller than it would be. So I don't have an exact number for you, but somewhere on the order of 1.5 to 2 times larger.
I see. Because of the size of the magnetics.
Yeah, mostly driven by the size of the magnetics, also by some of the storage elements, the energy storage elements. Because we're able to operate with 2 phases on the PFC, we can reduce some of the bulk caps, and same thing on the output there as well.
I see. And besides the size advantage, what else does the gallium nitride do for you?
Yeah, so the size is the big thing, but we're able to switch at faster speeds, which enables us to reduce some of the losses due to switching. And these devices are able to operate in topologies that you can't do with traditional silicon. So this totem pole bridgeless PFC, for example, you cannot do that with the traditional silicon because of the reverse recovery issues of the silicon devices.
Yeah, it's interesting stuff. Well, Robert, I think this is also a GaN circuit.
It is.
What is this?
So Lee, this one's pretty neat. So this is a 3-level 11 kilowatt ANPC converter. And so what we're doing here is we're using the gallium nitride devices. This is used in a solar application. And so for energy storage, various different types of inverters. It's a 3-level topology using both gallium nitride, and we have some low frequency silicon devices in here as well. But because of the gallium nitride, we're able to reach 11 kilowatts in a pretty small form factor here.
And how big is this compared to the silicon counterpart?
Yeah, that's another good question. So you can see the gallium nitride devices here, and we have a very small heat sink on the back side. These devices are 30 milliohm devices, and based on the switching speed and these devices, we're able to keep that cool in a small package. Again, you know, the solar inverter type of design that we have here would be much larger with silicon devices, and I'm not even sure that you could achieve that topology with those devices.
I see. And for our viewers that may not know what a bidirectional
right. So yeah.
that.
So this takes in DC and can put AC back onto the grid, or can operate in the other direction in order to store the energy in case of like a power outage, something along those lines. So this is a typical ANPC, which is an active neutral point converter. Another feature over here, we have our C2000 device, which is able to enable some neat protection features. You know, reliability is a huge concern in these types of circuits. And so some of the devices that we have here are able to enable that safety and types of things during operation.
Gotcha. Well, Robert, where should our viewers go to get more information?
Yeah, definitely. So both of these designs are on our website at www.ti.com/APEC. You can view both of these demos there, and hope that everybody is able to come and see what we have to offer.
Great.
So Lee, thank you so much. Appreciate it.